Hey guys, what's up? Thanks for checking in. Today we're going to be looking at a second method to solving systems of equations. Today we're going to be looking at how to solve a system of equations by substitution method. Let's dive right in. Now the substitution method, what is the substitution method? Really, it's as simple as this. I probably better remember to turn on my pen, shouldn't I? It's a method. Well, it is a method of solving systems of equations. Method of solving systems of equations by substituting equations within one another. Say that again. A method of solving systems of equations by substituting equations within one another. Now, really, that language can be quite complex if you think about it. But let's try not to think about it as much as we're going to take one equation and plug it into the variable of another. We're going to look at how this goes. So steps to solve. Steps to solve with step 1. First and foremost, we have to solve one equation for x or y. Now remember what this means. When we say solve one equation, it means we want to get one of those variables alone. When we say solve an equation, we want to find out what x equals or what y equals. It doesn't matter which, so long as we can get one of those alone. Now, step 2 is where this really comes in. Step 2 is where we substitute, or as I often like to say, plug in, because the two are really interchangeable. Substitute or plug in this expression into the other equation and solve for the variable. So whatever we have x equals or y equals, we're going to take what that x equals and we're going to plug it or substitute it into the other expression or the other equation, and solve for the other variable. Once we know what that other variable is, we're actually going to take that and substitute our answer, substitute or plug in, into the revised equation from step 1 and solve for the other variable. So a lot of this comes back from semester 1 when we were talking about solving equations and some of the basic calculator work that went with it. So we're really going to just dive into this. Let's not think about the steps so much right now as just using them to solve each system. So starting off with example 1, I'm going to keep these steps in sight. Number 1 has these two equations, and we're told solve each system by substitution. Now y is equal to 4x minus 1. But we're also told that y is equal to 2x minus 5. Now, go back to step 1. We want to solve one equation for x or for y. In other words, we want x or y to be by itself. Now, as I look at these two equations, I notice that both equations already have y by itself. Either one is totally fine. So now, we need to take and substitute this expression into the other equation. So, for instance, let me take this y equals. Let me focus right here on y equals 4x minus 1. That's the expression I'm going to use. Since that is what y equals, I'm actually going to take this 4x minus 1 and plug it in here. So now, instead of having y is equal to 2x minus 5, I'm going to plug in that 4x minus 1 for that y, and it's still equal to 2x minus 5. So now that we've got this set up, there's only one variable. It's only x. And this is where we solve for that variable. So much like we would solve when there's variables on both sides, we need to get all the variables on one side. And you should hopefully remember how to do this. We need to subtract 2x from both sides. You could have easily subtracted 4x from both sides. I just choose to do the 2x. That way all my x's are over here on the left. And 4x minus 2x is just 2x. I still have the minus 1, equals minus 5. Now I'm trying to get x by itself, right? This is just a two-step equation now. Add 1 to both sides so that 2x is equal to negative 4, and then divide both sides by 2. These are the same steps that we've taken since we first started learning how to solve equations. Negative 4 divided by 2 is negative 2. That's one part. But don't forget that we still have to take this, do step 3, and substitute this answer into the revised equation from step 1. So what I'm actually going to do is I'm going to take this x equals 2, I'm going to plug it into this equation that we used here. Y equals 2x minus 5. So then, when I plug this in for x, y is equal to 2 times negative 2 minus 5. Let me see. Y is equal to 2 times negative 2 is negative 4. And when we subtract 5, negative 4 minus 5 means that y is equal to negative 9. Don't forget from our previous learnings that the solution to a system of equations is not one thing or another, but in this case, it's going to be an ordered pair. Don't forget that. It needs to be an ordered pair. If it's not no solution or infinite solutions, it has to be an ordered pair. So x comma y means that our solution is negative 2 comma negative 9. Now I want to do the same exact thing for number 2. I'm actually going to redo this. The really nice thing about number 2, if I look at this, notice that we already have y by itself. Y equals 6x. So y by itself, we're going to take this, and we pretty much have to take this. We have to take this expression and plug it in for y down here. So let's go ahead and do that. So now, instead of having 2x plus 3y, I'm going to have 2x plus 3 times that y, which is 6x. Because we're taking 6x and plugging it in for y. And I'm going to have to multiply this out. So I get 2x plus 3 times 6, that's 18x, equals negative 20. I don't want to forget that negative 20. Now we're going to combine like terms and see that 2x plus 18x is equal to 20x. 20x is still equal to negative 20. And of course, to get x by itself, because that's our goal, we want to know what x equals, we're going to divide both sides by 20. And when we do this, the x's on the 20s on the left side cancel out, and x is equal to negative 1. Remember that this is just our x value. We still need to find the y value. And to do that, I'm just going to take this x equals negative 1 and plug it into this top equation here. So then, y is equal to 6 times that negative 1, because I took that negative 1 and plugged it in for x. If this is the case, then y is equal to 6 times negative 1, which is negative 6. And so the answer to this problem, the solution, is negative 1 comma 6. Now that hopefully we're getting the steps down, I'm going to go ahead and move this up so that way we've got number 3. And just to keep things clear, I'm going to change my colors up so that way you can see the difference. Now same steps follow. With number 3, we first have to solve one of these equations for x or for y. Now if you notice, this top equation right here, y equals x plus 9, already has us solved for y. We know what y equals. So now I can take that and plug it into this equation down here, and I can plug it in for y. So then my equation will go from being 3x plus 8y, and it will become 3x plus 8 times what y equals, and y equals x plus 9. This is all equal to negative 5. Now I'm going to have to do the distributive property here and take that 8 in like this. After that's done, I'm going to have 3x plus 8x plus 72 equals negative 5. By combining like terms, I'm going to get the 11x Now in this step, I'm also going to go ahead, I'm going to move that 72 over to the other side. We were going to have to do it anyway, but if we're combining like terms, I'm not going to be able to combine that 11x and 72 because they're not like. So I'm going to go ahead and I'm going to subtract 72 from both sides. So that way these 72's cancel out. And negative 5 minus 77 is negative 77. 11x is equal to negative 77, and to get x by itself, like we want, we divide both sides by 11. The 11's on the left side cancel out, and I get that x is equal to negative 7. Once again, this is just one of our coordinate points. We still need the other to get the full point. So if x equals negative 7, I'm going to take that, and I'm going to plug it back into this top equation here. So instead of y being equal to x plus 9, y is going to be equal to negative 7 plus 9. And negative 7 plus 9, that's the equivalence of 9 minus 7. It's just 2. So x equals negative 7, y equals 2. Negative 7, comma 2 is our coordinate point, or our solution for this system of equations. So all we're trying to do is take y equals or x equals, plug it into one equation, solve for the variable, then take that variable, plug it into the other equation, and solve till we have this coordinate point. Hopefully by now you have a sort of idea about what to do. Number 4 is yours if you would like to try it, but I'm gonna go ahead and move on to the next page and continue on. Now naturally, number 5 is going to be important because we need to be able to have one of these where it's x equals everything else or y equals everything else. Now as I look at this, neither equation is set up for that. Neither equation has just one variable equals something. There's always a mix. Here's what you want to look for. We want to take one of these equations and we want to set it up in y equals mx plus b form. Remember, slope-intercept form. And in order to do that, I need to find the equation where the variable that I'm looking for has just 1 in front of it. What do I mean by that? Well, for example, look here. This y in the top equation does not have a number in front of it. That number then is going to be 1. So this is just going to be y. This is exactly what we want to manipulate. So in order to do this, I need to get y by itself. And to get y by itself, I'm actually going to subtract 2x from both sides. So if I do that, these cancel out on the left side, and y, or 1y, is just equal to negative 2x minus 2. If that's the case, then I can take this y equals negative 2x minus 2 and plug it into this bottom equation for y. Then my equation becomes 5x plus 3 times that negative 2x minus 2, and that equals, or I should say that all equals, negative 8. Now we're going to solve this like a multi-step equation. That's all it is. I'm going to do the distributive property here, after which I'm going to combine like terms. 3 times negative 2x is negative 6x. 3 times negative 2 is negative 6. This all equals negative 8. And just like the last problem I did on the previous page, I'm going to combine like terms, and I'm also going to get this constant over to the other side. So 5x minus 6x is negative 1x. This is equal to negative 8 plus 6, which is negative 2. Now I want a positive x. I want a positive 1x. So I have to get rid of that negative. In order to get rid of the negative, I'm actually going to divide. I'm going to divide by negative 1. And when I divide both sides by negative 1, I'm going to get x, a positive 1x, equals a positive 2. So we know that our x value is 2. I'm going to go ahead and set up my parentheses. I'm going to set up my coordinate point. And you already know the next step. I'm going to take this x equals 2, and I'm going to plug it into that original equation, 4x, so I can figure out what y equals. So 2 times x is 2 here, plus 1y equals negative 2. Now 2 times 2 is 4, plus y is going to equal negative 2. And to get rid of that 4, I just have to get it to the other side, and so I do opposite operations. So these cancel out, and y is equal to negative 2 minus 4, which is negative 6. So the solution to my system of equations here is 2 comma negative 6. Fantastic. So number 6, a little more practice about this. Remember, we want to find an equation where one of our variables, x or y, has a 1 in front of it. When we look at the second equation, we see that y here has a 1 in front of it. So this is the equation I want to manipulate. I want to change this around so that y equals something. Now if I go to do this then, 2x plus y equals 9. I want to get rid of that 2x so that way y is by itself. So I'm going to subtract 2x from both sides, because what I do to one side I do to the other. These two x's cancel out, and y is equal to negative 2x plus 9. Now I'm going to take this, since y equals this negative 2x plus 9, I'm going to take this negative 2x plus 9, and I'm going to substitute it, or plug it in, for the y there in the first equation. So now I have 2x minus 3 times that negative 2x plus 9, and all of that equals negative 11. Same steps as number 5. Now I'm just going to distribute. I'm going to have 2x plus 6x minus 27 is equal to negative 11. And just like number 5, in one step, I'm going to combine the like terms, but I'm also going to take this constant and get it over to the other side. The goal of this, again, is to get my variable x completely by itself. So let's see. Negative 11 plus 27 is positive 16. So 8x is equal to 16. And to get x by itself, of course, I need to get rid of that 8. So I'm going to divide. 16 divided by 8 will yield me 2. And since x equals 2, I'm just going to take this, I'm going to plug it right back in to that first equation we used, the 2x plus y equals 9, in order to solve for y. So if x equals 2, then I've got 2 times 2 plus y equals 9. Well, 2 times 2 is 4. Plus the y is going to give us 9. So if I subtract 4 from both sides, I find that y is going to equal 5. So my solution to this system of equations is going to be 2 comma 5. Making sense? We've just got one extra added step on this second page where we have to flip some things around. We still want to do the same sort of thinking with number 7. As I look at number 7, I can tell you it's going to be a little bit different. Remember that the first step remains the same. We still want to get x or y by itself. So in this case, I see that this x has the 1 in front of it. This is what I want to change around, because I want x by itself. In order to get x by itself, I need to get that 5y to the other side. And to do that, I'm just going to subtract it from both sides. That way, it cancels out on the left. These cancel out, and x is now equal to negative 5y plus 4. Notice that this is what x equals. If this is the case, I'm going to take this, and I'm going to plug it into the other equation that I haven't touched yet. Now this is what x equals, so now I'm going to have 3 times that negative 5y plus 14 plus 15y equals negative 1. There's still some very similar steps here. I need to distribute this 3 into here. 3 times negative 5, negative 15y, 3 times 14, 42. And if you have to check yourself using a calculator, you may go ahead. But I'm already noticing something that's going to happen here. In one step, I can show you what's going on. If I look at this, I see I've got a negative 15y and a positive 15y. I want to combine like terms. This is what's going to happen. When I combine these two, I'm going to get 0y. Negative 15 and positive 15 cancel out perfectly. And 0y is not just y, it's actually going to be 0. So that 0y is going to disappear entirely. So what I have now is 42 is equal to negative 1. And the question that we have to ask ourselves is that true? The answer is no, that's not true. 42 could never equal negative 1. What, are you crazy? Because this is the case, we actually have no solution here. There is no solution to this system of equations. And so we write the 0 with the line through it. Numbers 8, 9, and 10 will fall similar to this. If you want to try these, you're welcome to. The equations that you'll have to manipulate around, this top one, because x is the equation with 1 in it, this one in number 9, and then this one here, number 10. You're welcome to try those out. And if you have questions, you know where to send them, hopefully. Otherwise, hopefully you have a great idea of how to start solving systems of equations using the substitution method. Have a great day, and until next time, I'll see you later.